A very good afternoon to all of you. So I again welcome all of you to a new topic, and this new topic is very important. So basically the topic is buck converter, DC to DC buck converter. Those who are new to this area of power electronics, I would like to shed a very important thing, some very important aspects of converter. Till this date, we have studied AC to DC converters. They may be either controlled or they may be uncontrolled. Okay, uncontrolled converters consisted of diodes, but controlled converter consists of thyristors, and the firing angle of thyristor is controlled by us. Now, in this part, basically we are concerned about the control of power flow. Okay, the control of power flow from a battery bank, okay, to another battery bank, obviously, or from a source of energy that generates power in its DC format. For example, consider a solar cell. A solar cell generates energy, that is DC power, and that DC power is sent to the battery or stored in the battery, and then it can be used by all of us. But as we all are aware that a generation of power is happening at a higher voltage. For example, a high voltage DC bus may be present here, and the storage of power will take place in a battery bank which is at a lower voltage. The voltage level of battery bank is quite low. So how this is going to happen? How we are going to simply channelize power from a high voltage level to a low voltage level without incurring many losses? Obviously, the power transfer will be there. Power transfer has to take place. There's no doubt in that part. But it should be efficient. Okay, the efficiency of transport for power should be very low. Second thing is that the transfer of power should take place effectively. Yes, the transfer of power should be effective. It should be cost effective. Okay, and the devices that we are using, those devices should be robust. Okay, those should not easily wear and tear away. Okay, so let's move forward. Okay, so another point, a very important point beside that point, is that the voltage should be stepped down. The voltage should be stepped down. It means that we need a circuit, a configuration in which a switch will be there. And how this step down of voltage can take place? It will depend on the duty ratio of switch, the switching cycle. The switching cycle will basically decide that at which duty ratio, at which level the voltage will get diminished. For example, let us take the input voltage as at 50 volt. Okay, and suppose the switch is there which is remaining on for 60% of the duty ratio. So if for 60% of the time, total time t, the power will be transferred, or the voltage at the load end will be 100 volt. Okay, so we can think that for 6 seconds the voltage is 100 volt. For the remaining 4 seconds, obviously it will drop to 0 because the switch is disconnected. So the net voltage that we are getting at the load terminal is 50 into 0.6, that is 30 volts. So in this way the step down of voltage will take place. I think it is quite clear. Now have a look at this diagram. Forget about everything, just look at this thing. There is a switch which is connecting the source voltage to the load. Okay, I will first of all come to this load and roll out this diode. It's very important. This switch will get on, or when it is turned on, it will connect. Have a look at this. Whenever Where's the marker? Yes, there it is. Whenever this switch is turned on, then it will connect this Vs to the load side. I think it is clear. Okay. And whenever it is turned off, then this connection is broken, and this source voltage is not applied at the load end. I think I am quite clear at this point. Now, as we all are well versed that this current will be, if the load is resistive, then this current will be of a square wave nature, obviously. So this will have harmonics. This will have some harmonics. If square wave comprises of harmonics. Those harmonics, okay, need not be present at the output. Are you getting it? What I'm telling you. Those harmonics should not be present at this end. For that, a capacitor has to be there, because the capacitor will provide a short circuit path for the higher order harmonics. Higher order harmonics will pass through the capacitors, and the average component of current will get applied at the load. I think at this point I am quite clear. Now, again, very good. It's very fine that the role of capacitor becomes clear. What will happen to now current? As for filtering out the ripples in current, for reducing the ripples in current, we will use an inductor. Okay. Basically, what is happening is that the inductor will not allow a sudden change in current. Okay, so obviously the variation in current will become low. The lower variations will be there. Those lower variations in inductor current will obviously affect the average current, because basically the inductor will be connected somewhat here. Take the example, it is connected here. Okay, inductor will be here. So the inductor current is nothing but it is the load current. Yes. So the average component of the inductor current is going to be applied at the load terminal, if I am not wrong. The average component of inductor current is going to be applied at the load terminals. Okay, and the harmonic component of current will get bypassed by this capacitor. This capacitor will bypass the harmonic component of current. I think this is quite clear. And there will be a freewheeling diode that is shown here in this picture. That diode will serve two purposes. First purpose will be there that, for example, the inductor is getting charged. Okay, for example, the inductor is getting charged, and it will store energy. That energy needs to be dissipated. The dissipation of that energy is very important. Else, where the energy will go? Because we all know that the current is periodic. Okay, the current is periodic, so the volt second balance will hold for that inductor. The voltage across inductor should follow the volt second balance, because the current is periodic in nature. Okay, so I think that till this point I am quite clear. One more important thing that I want to shed light is that, so basically this diode, often termed as the freewheeling diode, this diode, yes, this one, again I would like to show you just like this. Yes, this diode will facilitate the discharge of inductor's energy in this loop. Have a look at this. This is the loop. It will go from here, it will go like this. This is the loop. This is the loop that will be covered. And in this loop, like this, the energy will get dissipated. So I hope the basics chopper circuit is clear from this diagram. How the chopper will operate. It will be simply comprising of a simple RC circuit, and through the RC circuit we can get the values of voltage at the end of each cycle. It's very easy. You have to simply take that value at t, and by t by doing it, simply putting the value of time equals to t by 2, and we know that the voltage at infinity and voltage 0 can be calculated, and we can complete the analysis. I will show you in the next lecture. Till then, thank you. Thanks a lot.